morning, all of you. Today I'm going to explain the concept regarding discrete logarithm and Hellman Key Exchange. Myself, Kavya, from Assistant Professor from Dept of CSE, Cambridge Institute of Technology, Bengaluru. Discrete logarithm. Normally, y equals g to the power of x mod p is referred to as a modular exponential. This expressions can be rewritten as x equals log y base g mod p is referred to as a discrete logarithm. X equals log y base g mod p, you can read it as discrete logarithm of y to the base g modulo p, where p is a prime number and g be the generator of a group. What is a prime number? Prime number is nothing but a number which divides by 1 and itself. For example, if you take 5, the 5 will be divisible by 1 and 5 itself. So you can say 5 is a prime number. So you just take one more example, 4. 4, whether 4 is divisible by 1 and 4 itself? No, it is divisible by 2 also. So 4 is not a prime number. G is nothing but a generator of the group. So let us take one example. Z7 is a group. In that group, how many elements are there? 1 to 6. How you got these elements? So how you will get? First you go with 1. Whether 1 is relatively prime to 7, you need to check. So that means relatively prime means the GCD of these two numbers are 1, you need to check. So 1 and 7, the GCD of 1 and 7 is 1. So next check with 2. 2 and 7 also 1. 3 and 7 also 1. Like this you need to check until 6. Next, because it is Z7. This is nothing but the elements of Z7. Afterwards, you need to check with 2, then 3, 4, 5, 6. Whether 2, 3, 4, 5, 6 are the generators of Z7. So 2 to the power of 1 mod 7 is equal to 2. 2 to the power of 2 is nothing but 4 mod 7 is remainder. You have got it as 4. 2 to the power of 3 means 8. 8 mod 7 is equal to 1. So modulus operation will give you the remainder. So whenever you get 1, you need to stop. Next, you go with the 3. 3 to the power of 1 mod 7 means 3. Like this, you keep on finding out until the remainder you get 1. So you have got 1. So what are the elements here? Here you have got 1, 2, 3, 4, 5, 6, which is equal to Z7. So but in 2 only 1 and 2, which is not equal to Z7. So which number remainders you have got which is equal to Z7 is nothing but that number is nothing but a generator of Z7. Here 3 you have got the elements remainders which is equal to Z7. So 3 is called the generator of Z7. So likewise you need to check with 4, 5 and 6. So you can have more than one generator for Z7 also. For our one, I have just explained with by taking 2 and 3. Here 3 is called the generator of Z7. Next, discrete logarithm. Now suppose if they are given g value and x value and p value, it is easy to find out y. Why? See here, y equals g to the power of x mod p. So what is g value? 2, and what is x value? 7 mod 13. So 2 to the power of 7 mod 13 will gives you the remainder 11. But finding out x given g value, p value and y is referred to as a discrete logarithm. Here for examples, so first example, x equals log 2 log 4 base 2 mod 30. This can be rewritten as I have shown in the first slide. Here this expression you can write in this way also. This can be written in this way also. So I am just they have given with this kind of problem. I will just going to explain replace with this kind of expressions. So this can be rewritten as 2 to the power of x mod 13 equals 4. So for which value of x you will get the remainder 4, you have to trial and error method you have to do. First you substitute x value equals 1. 2 to the power of 1 mod 13 will gives you 2 as a remainder. It is not equal to 4. So x value is 2. 2 to the power of 2 means 2 into 2, 4 mod 13, which is equal to 4. So x value is nothing but 2. In the similar way, this problem can be written as 2 to the power of x mod 13 equals 10. So for which value of x, if you perform modulus operation with respect to 13, will gives you the remainder 10. So you trial x value equals 1 will gives you the remainder 2. 2 means 4 will gives you the remainder 4. 3 means 2 2s are 4, 4 2s are 8. Mod 13 means will gives you the remainder 8. 4 means 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 mod 13 means will gives you the remainder 3. Like this, if you keep on checking for x value equals 10, will gives you the remainder 10. The same way, this can be written, the third problem can be written as 2 to the power of x mod 13 equals 7. For x value equals 11, you have got the remainder as 7. Next concept is Diffie-Hellman Key Exchange. It was developed by Diffie and Hellman in the year 1976 with the idea of using two keys. That means one is private key and the public key. By the name itself, you can see key exchange. Key exchange means between two persons you are exchanging the key, exchanging the key. This was introduced by Diffie-Hellman, so the name it was given as Diffie-Hellman Key Exchange. What you have to do first is you have to assume both A and B. Here the two parties are nothing but A and B. A and B know the base value and the modulus value. Both A and B knows the base value and the modulus value. Let us see with this diagram. A and B are the two persons. A and B both are knowing G value and P value. The first step is the person should choose a random number A and the person has to compute G to the power of A mod P. That should be sent to the other side. That is nothing but a P. Next, what B has to do is, if the B has to choose a random number B, the condition should satisfy. What is the condition? The chosen random number should be greater than 1 and it should be less than P minus 1. And the person has to compute G to the power of B mod P and that has to be sent to the A. And again, what A has to do upon receiving the message, it has to perform one more operation, G to the power of B mod P whole to the power of A, that is equivalent to G to the power of AB mod P. And upon receiving A's message, B should compute same way G to the power of AB mod P. By doing this, they will exchange a key between A and B. See here, A chooses a random integer A that should be greater than 1 and it should be less than P minus 1 and it's computing the partial key G to the power of A mod P and send this to B. B also chooses a random integer B and it's satisfying this condition and computing G to the power of B mod P and sending this to A. On recipient of A's message, A will be sending message to the B. What B has to compute? G to the power of A mod P whole to the power of P mod P. That is equivalent to G to the power of AB mod P. On recipients of the B's message, A also should compute G to the power of B mod P whole to the power of A mod P is equivalent to G to the power of AB mod P. By doing this, both A and B share a common secret, that is nothing but G to the power of AB mod P. Let us see this scenario with one example. See here, I have told already both A and B know the values of P and G. Let us take that P equals 13 and G equals 2. What is the first step? A has to choose a random number, right? A has chosen a random number that is nothing but a 5. What is the condition? It should be greater than 1 and it should be less than p minus 1. So p minus 1 is nothing but 12. So it is less than 12. So how to, you need to find out 2 to the power of 5 mod 30 equals 6. Like this same way, and this has to be sent to the A. Sorry, this has sent to be B. And the same way, we will choose a random number that we have taken as 4 and computes 2 to the power of 4 mod 30 is equal, remainder you have got 3, that has to be sent from B to A. After receiving B's partial key, means what has been received, what is the B's partial key? That is nothing but a 3. A computes the shade secret. See here, that is nothing but a 2 to the power of 4 mod 13 whole to the power of 5 mod 30, that is equivalent to, this value is nothing but 3. 3 to the power of 5 mod 30 equals to 9. In the similar way, after receiving A's partial key, we will compute the shade secret as 2 to the power of 5 mod 131 whole to the power of, sorry, it's not 131, it's 13 whole to the power of 4 mod 30 will gives you the answer 9. So A and B has exchanged the key, that is nothing but, both have exchanged the key, is nothing but 9. In this scenario, there is a man in middle attack. One kind of attack can be possible on Diffie-Hellman Key Exchange. The name is called as a man in middle attack. You can go with the diagram first. See here, A is choosing random number A and it is computing this, and the message was sending from A to B. What attacker will do? Attacker will interrupt this communication and it will choose a random number C and it will compute G to the power of C mod P, and that will be sent to the B. Instead of sending G to the power of A mod P, the attacker has sent G to the power of C mod P, which is that G to the power of C mod P is nothing but an attacker has chosen some random number and it has been calculated G to the power of C mod P and it has been sent to the B. What B will do? B will choose some B random number satisfying the condition and it will compute that and it will send some G to the power of B mod P. What this is, the attacker will interrupt this B's message also, and this person attacker will whatever the chosen and computed G to the power of C mod P is there, right? The same message will be sent to the A. What A will do? It will compute G to the power of AC mod P, and what B will do? G to the power of BC mod P. Here, what the A and C has exchanged the common secret because G to the power of AC mod P is being calculated, and in this C and B has exchanged the common secret, that is 2 to the power of BC mod P. Let us go with description. See here, attacker C chooses an integer C and computes G to the power of C mod P. What will do? C then interrupts A's message to B and substitute it with G to the power of C mod P and send this instead to the B. Whatever the A has been sent, that message was interrupted by C and C has sent his own message to the B. In the same manner, C also interrupts B's message to A and instead of sending B's message to A, it will send G to the power of C mod P. So after the message transfer, B will compute G to the power of BC mod P and A will compute G to the power of AC mod P. So C also computes two secrets, that is nothing but G to the power of AC mod P and G to the power of BC mod P. Now both A and B might think that they have a secure channel for communication by encrypting all the messages to each other with a common secret. Instead of that, A shares a secret with C and B shares a secret with C. In reality, every message encrypted by A to B can be decrypted by C and possibly changed and re-encrypted with the secret shared by B and C. In this, likewise, every message from B to A can also be decrypted and possibly modified and sent by the B to A. This is an example for the active man in the middle attack. This is a diagram. Thank you.